have a question about what's right here?
Yeah, but I think you're gonna do it.
Can anyone tell me? First of all, some of you with the wording get confused. What's a square root? A radical. Good. A radical. Looking for pairs of two, right? Not a cube root, but square root, radical. What do we use radicals to undo or to get rid of? Squares. Do you guys see any squares in these two equations? One there and one there. Right? Sure. If the radical is of negative. There can be maybe negative somewhere else. But if it becomes positive, it's okay. Always use like negative whatever.
It is a negative on each side. Radical is on negative equation.
So, as you guys are doing A, Rob and Jordan, what did both of you guys do that you're getting a negative?
Subtract.
Subtract 20 and then you divide by 5.
So far they're trying to get rid of the 20 and the 5, and the purpose is to get that squared thing alone. So to get x squared alone, you have to start with a minus 20. So you end up with 5x squared, and Johnny's saying what to do next. Yeah, get rid of that 5. We're just trying to, one by one, get things away from the x squared. Now, we have x squared, remember.
But you can because
Yeah. Hold that thought though. In order to get x alone, if there's a square, we just said, what undoes a square? When we put in a square root, we always put a plus or minus, just to be safe. But why were Jordan and Rob both saying, wait, if there's a negative under a radical, what do we got? Error. And if you try that in your calculator, you guys can test it. Error, meaning no solution.
You can't have a negative.
Exactly. Does that make sense? Yeah, can't be a negative in the radical. Or if there is, I mean, there can be, but we just have to say no solution. All right, for letter B. What's your guys' advice? Where should we go?
divide by 2. No.
Yeah. No, don't factor. It's already factored. But if you look, this guy is the one that's squared, and so Jordan's noticing that 25, and a couple others of you have already said that. That 25 isn't a part of that.
Yep.
So can't I divide both sides by 25? Now some of you might try, well, we're getting the squared alone. And the reason we're getting the squared alone is because once we got the squared alone over here, what were we able to do? Square root.
Okay.
So once we get the squared alone over here, well, hold on. 9 over 25, some of you might want to do a decimal. I'm going to say just leave it. Because they don't reduce. 3 goes into 9, 5 goes into 25, that's it. Rob, bring your phone up. So if we're trying to do squared, if we're trying to undo a squared, what do I need to put in? Square root. So I'm going to do a square root of this side. Wait, when I put a square root, what else do I have to not forget? Yeah, I do both sides though. What am I leaving out?
Cancel out.
It does cancel out.
Plus or minus.
Plus or minus. So I have my plus or minus. Now you guys are like, yes, it does cancel out the squared, and what do I end up getting? Now, here's the struggle. I got myself a pencil. Guys, why am I showing a square root on top and a square root on bottom? What am I trying to show you? Am I trying to simplify my radical? Yeah, exactly. Jay already said, like, hey, wait, I know square root of 9. He knew it. It was 3, right? Yeah. So square root of 9 is 3. What's square root of 25?
5.
What's still on the other side?
1.
Now, here's a struggle. It's been a little while since we did these. Not a super long while.
Two
Different equations. I need to split this up into 2 different equations. Remember, I have the plus or minus. I need 2 different equations. I'm going to do the positive 3/5 and what's my second equation?
Negative 3/5.
Okay. I'm going to get my
You add.
Yeah, you do the opposite of subtraction. So I'm going to go ahead and add 2. What I you're doing one side, I gotta do the other. Now, you can do the mixed number, that's not bad. It is gonna be 2 3/5. Some of you might try to do like an improper fraction. That technically is okay though. That is one way of saying it. I'm gonna go ahead and put an or just for an improper fraction because you could have also written it as, what would that be, 13/5?
Yeah.
But I also have to add 2 on this one as well. This one's a little bit harder. So I'm gonna go ahead and write it this way. X equals 2 minus 3/5. Does anybody know what that would be? So if you guys are fairly good at fractions, you might be able to get 1 2/5 without showing any work. And that is a proper answer. That's not wrong. That's not bad. However, for those of you guys who are like, I don't know if I could have gotten 1 2/5. The other way, those are 2 answers. The other way is you could have gotten a common denominator. Remember, put over 1, 5 over 5. This way works too. Yeah, I'm not so sure you're focused. Let's go ahead and work on that, okay?
I like that.
The bottom or the top?
Bottom.
Yeah, I think I do too. It's kind of more straightforward. The other one's a little more out there. Hopefully you see it. So both ways work. You can have the mixed number form or you can have the improper fraction form. I like them both. So if you guys look at the 7/5, isn't this 5 goes into 7 one time? 2 left over. So it's the same thing as 1 2/5. Question. What were in both equations at the very beginning that we had to get rid of to get to x? There was a square. So letter A, x was being squared, right? And in letter B, x minus 2 was being squared. Question, what did I have to bring into the equation on both sides to undo the square? The radical, the square root. I had to bring that in to get rid of the square. 2 things I had to be very careful of. Number 1, plus or minus. And number 2, be careful of the right hand what's underneath. If it's a positive number, keep going even if it's messy. If it's a negative number, no solution. What if it was 0? That's the square root of 0.
Zero.
Oh.
Zero.
So it would have just equaled 0 on that side, and then I would have kept solving. Only one answer would have been the result.
Did you have to divide by negative? Did you like the radical the whole thing?
Oh, for 25?
Yeah. You radical the whole
You
thing?
technically could have, because then you would have had square root. They would have had the square root of 25 and the other.
Yeah.
So then you would have had a 5 that would have gone.
Oh, so
It just gets a little rough because some people get confused because you would have pluses or plus positive negatives plus minuses on both sides and they would have gotten
the same thing.
Alright kiddos, good job on the warm up for today. Can I just show you real fast what we're doing?
Yeah.
For the rest of the section, then we'll go back to our homework questions.
Okay.
What's the title?
Solving radical equations.
Okay, pause.
Did we do that?
Hold on. These are solving quadratic equations that have squares. So if you want to think about it, solving equations with x squared or with square expressions of x. There wasn't like a nice name for it, we just called them quadratics. But we solved with square roots. Now what's different is the equation is going to have a square root. Well, the equation already has a square root. What am I going to do with that? I'm going to have you guys take notes in a second, but can you just look at the example? Don't take notes. Don't take notes. We'll come back. We'll come back. Look at your equation. Don't take notes. It's okay. Just look at the example. Look at the example. We have a square root, right? We have a square root. Question. It's not a square. It's a radical, yeah? Well, what do you think my goal is in this equation? What am I trying to get out of? I'm trying to get the x alone, just like I was before. But in this one, well, what's the first thing you think I should do in order to get that x alone?
Oh, that's 7.
So if I add 7 on both sides, what's left on the left-hand side? Tyler, Rob, Jordan? Square root of x. What's left on the right-hand side? 3 plus 7. 3 plus 7. I have to add 7 to both sides. Now wait, I still need to get to x. Square. There is a square root already. What square root in order to be able to cross out.
Where?
Over here, I had it squared already, right? I had it squared already. I put in a square root. What if I have a square root already? What am I going to put in? Square.
So you just add it?
Well, I put it in. Remember how we just put in the square root? Now we're just going to put in the
Then you square it to 10.
square. Careful wording. There is a square root, or rather, a square root already. I'm going to square both sides. No root. I'm going to square both sides. So if I square the left, yeah, in algebra, if you do something to one side, you got to do it to the
Other.
Is this going to work out?
Yeah. X equals C.
Because those are going to cancel?
X equals 1.
Does that seem super crazy, guys?
I like that.
We've done that. How would we check?
That's pretty good.
You guys know how to check. Don't you plug in?
Yeah.
So double checking. Square root of 100 minus 7. Isn't that 10?
And
Minus
minus
2. Alright, kiddos, let's go ahead and go back to homework because that's today's lesson, basically. It's a little harder in a couple ways, but that's not it's not bad. But I'm pretty sure we might have some questions on 5 through 20, comma, 21 through 35. There were 2 homeworks, 59 and 60. Yeah, this is Friday's homework. Angel, go ahead and take a picture quickly. I have the evens already ready to go. And I'm going to freeze the screen. And as you guys check your evens, I'm going to take questions as they come from homeworks 59 or 60.
Number 18, number 8.
8? Okay. Let me get the evens up. Angel, you got your picture?
Yeah.
Cool.
I use the restroom.
Yes, you may, since you're not checking. I heard number 18. I'm going to scroll down in just a second. What else we got, Ava? 25.
14.
14. This is starting with number 59. I'm going to scroll down so we can get to number 60. Have you what? Any others from, so far, what's on the screen is 5 through 20. What's on the screen is 5 through 20 all.
Number 14.
Okay, good. So we have 14, 18, 25. Oh, and 10. I'm going to go ahead and scroll down. I'm going to go over there just so I can start writing some of these problems down for us to look at, okay? Alright, let's see some more of the evens. So this is going to be, this should be, the evens from number 60. It started at 21, right? There we go. The graphs don't have to be perfect, but they should display the same, like shift down, shift left, shift right, and up. Okay, you guys needed to have some tables, right? Without a table, I'm not sure you'd be able to magically figure out where these things went.
I did it on scratch.
Ah, but what have I always said about scratch paper? Staple to your homework because it's a part of homework. Without it, there's no proof. Alright, kiddos, do I need to scroll down one more time? A couple more seconds? Okay. I'm writing down people's questions. Can I scroll down now? Okay. It's not going to lose everything, just part of it. Don't worry, don't worry. Okay, let's make sure that we're actually talking about what we should be. All right, I want to hear what questions you guys have on the rest, but I'm just going to write down number 25 really fast. This was from homework 60. All right, I have the directions written down, and then describe the range. Any more questions that we need to add from homework? The end of homework, I should say. Diego, go ahead. 28. Caleb, what you talking about then? Okay. You've been really distracted today. I really need you to focus in, or else we're gonna fall really behind. Okay, I heard number 28. I think that's also that's a comparing one. Okay. Kiddos, for the comparing, that word in homework, let me go ahead and pull the homework up really fast. For this word compare. For this word compare. Didn't we do a whole table in our notes on Friday about what words to use when we're supposed to answer that question of comparing? Okay. We did a whole table saying, hey, these are the words to use when it says, first of all, graph. And when it says, second of all, compare. And you're comparing to, just in case you're wondering, who on earth is this guy? Why is he so special? We're comparing the square root of x, because remember, that's the parent function. That's the non-transformed function. Okay, I think I have everybody all ready to go, so let's go ahead and look at these questions. If you guys don't have the homework done, you were absent on Friday or something else happened. If you don't have these questions done, you better be paying extra careful attention because you're already starting today out behind. Okay?
Really?
Because you need to catch up. See what I mean? So pay super close attention because these are the questions other kiddos got stuck on as they did homework. It'll be on the video if you want to watch it tonight, people that are behind. Because you're going to come to these as you try to catch up on your homework as well. Alright, so let's go ahead and start with number 10 and 14. The directions are exactly the same. Kiddos, we're just reviewing real fast. How do we think about domain? Radicand. Take what's underneath, right? Remember the box. Take what's underneath. Take the radicand. I gotta make sure you're looking at it. Take the radicand, and what do we do to the radicand? Greater than?
0.
Or equal to.
Equal to. Yeah. Greater than or equal to 0. Good. Get that 0. Greater than or equal to 0. What do we do for number 14? I haven't finished, but what do we do for number 14? Take the negative x minus 2. Take the radicand. What are we going to set it? 0. And what's my sign, my inequality? Yeah, same thing. Anytime you have a radical equation, take that radicand, take what's underneath. If it's an even, well, what we call a square root, set it greater than or equal to 0. So for number 10, kiddos, how are you supposed to finish that domain? Yeah. Subtract 7 on this side, subtract 7 on that side. So what do I have left on the left? Just x.
So like a px doesn't matter at all.
Px, remember, that's just describing. That's a snazzy name for y. It's a snazzy name for y equals. Yeah, no stress. So what's 0 minus 7? 10. That makes sense, right? For number 14, how do we solve? Okay, we start with the minus 2, but we add it, right? Good. Add 2. Now, guys, this one's a little bit trickier because we didn't get to review all of our inequalities before this section. So, on the left, don't we have a negative x left over? Greater than or equal to, what's 0 plus 2? And how do I get x alone if there's a negative? I pull it to the other side. I can divide or I can multiply. Do you guys care which one?
No.
Just move it.
And I'm going to go ahead and just divide by a negative 1 so you can think of those times. Divide by a negative 1. Now wait. There's something super special with inequalities. When I multiply or divide by a negative, what happens to my inequality?
It's less than.
So instead of greater than or equal to, I have to flip it. That's a rule from a while ago. But when you multiply or divide by a negative, you have to flip the inequality. So our domain, got couple of questions on 10 and 14. That wasn't bad, right? You said to use your notes and follow the directions. Use your notes and carefully follow the directions. Now, number 18 was a matching problem, which those are kind of hard, unless you realize, well, wait, if I got the graph, shouldn't I be able to match it to which one's right? Okay, so let's review real quick, because the last three problems say graph. How do I start graphing a radical equation?
Make a
Table.
table.
But wait, the tables, you need to know where to start. Do you remember my trick to know where to start?
Start with the domain.
So I'm going to start with the domain. I'm going to make it kind of small and off to the side because that's not exactly the point of the problem. I'm going to start with my domain, negative x plus 3. Guys, I'm going to do it kind of quick because this isn't the point of the problem. But it is a trick to help everything go a little easier. Divide by negative, divide by negative.
So
Remember how we have to flip the inequality?
if it's negative, right? Or do you always flip it?
Whenever you multiply or divide by negative.
You flip it. Oh.
Now, because of that, if the domain is x less than or equal to 3, then kiddos, when I go to make my table, where am I going to start plugging in? Oh, come on.
No,
Do you remember why we did the domain?
So plug it in.
we're in X.
I plug what into x?
The domain into the table.
Start with the number that's in the domain. Does that make sense? Start with the 3. Now, hold on. The inequality says less than or equal to 3. Am I going to go to 4 next?
No.
Someone help here for now? Careful, we go. If I try to plug in 4, it's going to be, it doesn't work because it says 3 or lower. So what's something lower than 3? Maybe that's where I should go. Yeah. So go 3, then 2, then 1, then 0, then negative 1. That works. Now guys, I'm not going to go through plugging in every single one. I'm just going to show you one of them. Remember we plugged this into the x spot. So I have negative 3 plus 3. Does anybody know what that one's going to be?
That's gonna.
Yeah, negative 3 plus 3 is 0. Square root of 0 is 0. Now if you keep on plugging in, I'm going to go kind of fast. The next one's going to be 1. I plug in 1
Oh yeah,
I get
I
square root
remember
of
this.
2. I don't like square root of 2. If I plug in 0, I get square root of 3. I don't like that either. Ooh, this one's good. Negative 1 looks nicely. Negative 1 is 4. Yeah, that one's going to be square root of 1. That one's going to be square root of 4. That should be enough to get us a picture. We don't necessarily need everybody.
So we don't like only use 3 or 4.
Yeah, you just need to get enough. Get enough to get by. So I'm going to go ahead and take these points to my picture. And kiddos, if you were able to get these points, you probably would have been able to narrow down which one was right.
Oh.
But guys, hold on. Wait. What was the clue, or what was basically the hint that got this whole party started?
The domain.
Domain.
That was my hint. I told you on Friday. I know the weekend's hard because a lot of you guys don't do your homework until way after class. Okay. But it was in your notes. Start with domain. Put that in. And why did I go down in this one? Less than or equal to. I would have gone up if it was greater than or equal to. So then if you guys looked at this problem in number 18, you were supposed to match. Question, which of these looks like the picture that I have over here on this side? B. Dylan, B looks kind of like it, right?
Yeah.
See how it goes this way?
Yeah. I would be.
Okay, good. Now I'm going to go. Kiddos, remember, our lesson isn't bad. You guys stop learning during this time. I should stop. I want to help. Here we go. Number 25. Really quickly, I know there are a few of you that are like, I got it past this point. Maybe you needed comparing words, etc. But let's just pause for 1 second. Can you guys take a picture? I'm going to go write this in the blackboard. So we're going to go back to notes. We're going to do a few more examples. But I do realize there are a few of you that are like, I don't need all these answers. That's okay. Now, guys, listen. Why do I do homeworks like this that have lots of little bits and pieces?
Because it helps us.
Well,
Really?
I could have done 3 through 29 all.
Yeah.
Oh.
Okay. Okay, so this is a good thing, right? I'm trying to help us focus on only a few problems. Does that make sense?
Thank you, Mr. How about you stand up?
Hey. Guys, I'm done. I'm done. As soon as you guys have the homework, go ahead and put it away. Just a few of you guys might want to write it down and use it. Angel, why are we still talking about? Be a part of the solution, not the problem. Be a part of the solution, not the problem. Rise up. Hey. Be a part of the solution, not the problem. When you guys add in extra comments, you're being part of the problem. Part of the solution is like, no. I'm not going to let it go. Okay? Keep going up. Okay, so we're going on back. It's written on the backboard if you guys still need to see it and didn't get a picture yet. Okay, but I am going to go ahead and help out with number 25. Because I heard a few of you that were like, it got hard at the end. So here we go. Number 25. Yeah, right? So what's my way of, guys, you're right, some go one way, some go another, some go up, some go down, some go right, some go left. Dylan, where did I say to start for the last problem?
25?
No, for the one right before. Where did we
Oh,
start? What was the first thing we did?
We did the minus x plus 3.
Yeah. Guys,
Oh.
you got it.
Oh, you grabbed it. Okay.
No.
Okay, all right.
Hey.
Hey. Griffin, go ahead and bring it up. That is illegal on campus, right?
It is.
I don't get people in tons of trouble if I see you chewing it, because I'm hoping that you're focused with it, but if we're passing around stuff, you're just distracted.
Okay, Tyler, stop.
You'll see Mr. Kim. He's the wall.
Alright guys, you're staying a minute. Stand 2. Stand 3. Stand 4. Yes, I need to hear a little. Should I try that? I want to help you pass. Do you care about passing? I'm not sure you're going to be successful. So if you do care about passing, then help your classmates out who are so distracted. Number 25. You guys are bored with no more questions. Get out your book and start doing tonight's homework because I showed you what tonight's homework is. Alright, number 25. If you have an A in the class, you can go in the back in the class. For right now, for the second, for your guys' attitudes today, you get an A in the entire class, and you go in the back and quietly work to turn the desk the other direction. But otherwise, just a hint, that's maybe one person. Maybe 2. So the rest of you guys, Corey's not you, let's work on number 25, or you may quietly at your desk. You may quietly at your desk work on the homework. Number 25. My hint on 25, on 18, on 28, my hint is start with the domain,
Which is the Vatican.
which is the Vatican. So take the Vatican, set it greater than or equal to 0. The Vatican greater than or equal to 0. You guys have seen me solve plenty of equations, so I'm just going to move on. If you have struggles with how to get x alone, you need to come talk to me. And we need to figure out, talk to your parents, get your private tutor to try to make it through this course. Otherwise, we should be able to know to subtract the 2. The domain is x greater than or equal to negative 2. Now, some of you guys that struggled with the last problem, help me out. In order to graph, I need a table. Can anybody help with what you see right here with the domain? What is the first x I'm going to put in my table? Good. The domain helps me know where to start. Now, anybody tell me another point in the table? Why am I going higher table? But I agree. Greater than or equal to. No. Check out the sign. Greater than or equal to means I'm going up, right? So I'm going to start at negative 2, and I'm going to go up. So I'm going to go up to negative 1. And then, yeah, I can try 0. Now I'm going to stop right there. Because remember how sometimes when you plug in, it gets something yucky and like decimal? So let's go ahead and if we plug in negative 2 up above. Careful, that's plugging into the x value. If I plug in negative 2, then I'm going to go ahead and do the square root of negative 2 plus 2 minus 2. As we simplify, do I start with the minus 2 or do I start underneath the radical? So what's negative 2 plus 2? 0. Don't, I haven't given it to you yet. What is the square root of 0? 0. What's 0 minus 2? Negative. Good, so I'm going to plug in a negative 2. Was that a pretty nice square root to do? Yeah, I didn't mind it. What am I going to do as I keep going on? I'm going to keep plugging in. To help us out really quickly, if you plug in negative 1 plus 2, I'm going to do the math fast. Negative 1 plus 2 is 1. Square root of 1 is 1. Minus 2 is negative 1. Guys, this is work for you to show, but I'm going over homework questions. The lesson was not about plugging in. If I plug in 0, do I like this plug-in? 0 point plus 2 is square root of 2. Is that a nice one? No. So maybe we could try with, maybe we could try with 1. Barry's saying that one's not good either. Go with 2. Why is 2 better? 2 plus 2 is 4. Square root of 4 is, and 2 minus 2 is 0. So Dylan, make sure that you meet with both keep in space that you can go ahead and get Mary 60 tomorrow. Alright, so as we go, kiddos, maybe you can get some more points, but for right now, we've been super careful. We've gotten our domain. We've carefully plugged in points following what our domain said to do. So we can go ahead and try to graph and see if we have enough information to be able to answer our questions. So I'm going to go ahead and plug in negative 2, negative 2. Graphing my points one at a time, as is applies. Negative 2, negative 2, negative 1, negative 1, 2, 0. Can you see it split into one side? This is the beginning. And then I'm going to follow, as my points go, I'm going to follow my school. Question. How am I supposed to answer the question? We've gotten the graph done. That's a check. But what about the second part? What's that word?
Range.
Range. What does that mean?
How
How high does it go?
high?
But to know how high does it go, I have to ask myself, well, how low does it go? Guys, how low does it go?
Negative 2.
Yeah, right? It goes below 0. But look at your y values. This is y equals 0, y equals negative 1, y equals negative 2. It goes down to negative 2. So how am I going to explain my range? Is greater than or equal to, because it's above, right? It's higher than. How low does it go? Negative 2. So what's my range? Y greater than or equal to? Jordan, go ahead, kiddo. I'm looking at the next problem. You should be able to get it back tomorrow. My AP calculus classes, which are 3 different classes of students, about 75 kids have their AP tomorrow. So that's kind of been my focus this weekend, is getting them ready for that. I usually try to let you guys see it first. So you'll get it back first.
Wait,
You guys also have a question on, now's not the time for this. You guys also have a question number 28, so I'm going to end there today, okay? Number 28. Barry and Alan, you may be working silently on your own, but you may not be talking right now. Number 28 is the square root of 2x. Square root of 2x, that's our very final one. And the directions are graph at number 1 compared to the square root of x number 2. Now guys, I'm not going to graph it again, at least I'm not going to go through all the details. Because you've seen me do that twice now. What I'm going to do instead is just kind of walk through the process with you really quickly. Barry, the last time I told you. Absolutely no time. You may be working on your own alone, but no time. It's okay. I'm not mad as long as you obey. I've already asked you to obey. X is greater than or equal to 0, which is why I'm going to make my table start at 0. Work my way up. How come up? Rob, how come up? Okay, so it's greater than. Now wait, I'm not going to start at 2. Where am I going to start? Where does it tell me to start? So I'm going to start at 0 and work my way up. I'm actually going to go up to 8. Let's see if you guys can figure out why. When I go to plug in, square root of 2 times 0 is 0. That's good.
Square root of 2 is, or square root.
Square root of, 2 times 1 is 2. Do I like that one?
No.
Maybe I'll ignore him. How about this one? Square root of 2 times 2 is 4. I like him. Why did I choose 8?
Because it's square root.
15 is 4.
Yeah. I take the 8, plug in. 16 is one that I know. What's the square root of 16?
8. No, that's not 4.
Alright. So kiddos, that was all to get the graph. But to be honest, the point of number 28 was not the graph. It's good if you can get it. It's good if you can get it. But what was the second part of the directions? Compare. Okay, so I have my 0, 0. I have my 2, 2. And I have my 8, 4. Okay. Some of you might have realized we had to do a lot more tick marks going this way. We had to do a few more tick marks going that way. So something definitely changed, but what? Now, maybe you have square root of x in your mind and you can say that that thing didn't shift anywhere. It's still at 0, 0, so maybe you know it's not a shift right away. Maybe as you look at it, you also say, wait, it's kind of going the normal direction, so I don't think it was a flip, a reflection either. But at the end of the day, kiddos, we had that nice big old table. And that nice big old table, I gave you on Friday, and I said, all the comparing words you need are right here. Can you guys look at these categories? This was actually in your book 2 pages back from the homework. Is there, in the square root of 2 times x, is there addition or subtraction going on? In the example we're just doing. It's square root of 2x. 2 times x. None of this was going on. Were there any negatives? Square root of 2x. No? Okay, so far it's not this, it's not that, it's not that. Square root of 2x. Ooh, yeah, multiplication. Now, we have to ask ourselves, square root of 2x, is that inside or outside? Inside. So now we've gotten to the category that we need. If we're on the inside, last but not least, we have to ask ourselves, is it a shrink or a stretch? 2x is a bigger number, unlike 1/2 x, so it's going to be a shrink. So take all those words and put them together, and that's your answer. What kind of shrink? Over here. Horizontal. Shrink by, you could say by a factor of 1 over whatever number is there, and as someone already brought up, 1/2 is the correct answer. 1/2 is the correct answer. So we literally just had to come to our table, fit it into a category, and we got all of our comparing words. It's kind of like we're cheating in a sense. We're just using the table. So I'm going to go ahead and say, all right, how do we compare? We can say this shrink or stretch? Shrink by, I think Haley, you said it, and maybe Ava. By what? 1/2. Justin, thank you. I know it, a few people have said it. I was just trying to double check. This is a horizontal shrink by 1/2. There we go. We got our graph and we got our comparative language, our wording to use. I'm going to go ahead and go back to notes, kiddos, because I have just a couple examples and then we're going to be done. Now, if we can finish earlier than the extra 4 minutes that I put down, I'll probably let you go. Except for maybe a couple of you I still need to talk to. However, we got to get some stuff done. So if you guys want to do the questions and stay a little bit longer, that's okay. Jay, what were your questions?
Oh, can you make that bigger on the clock?
For the test?
Yeah.
Maybe. I can see that you guys know how to use this. And we'll know that for the review, from the review. Go on.
I don't know if it applies to this section, but will you ever use word problems?
Whatever you use.
Like as a
In life, math needs to be applied to word problems, but for our purpose this year and for how behind we started this semester, we've been focusing on at least hopefully getting the foundation to the math so that we can add words in a future course. Does that make sense? Now, the one thing I do need you guys is to at least be able to understand the words and directions. We're just trying to get those words down.
And normally, like, Alg1AB probably do it.
But we have to read directions. They tell us what to do. It's hard. It's hard getting them to do that. Kiddos, we have 4 examples. People who've been working on homework, you might want to check it out just to make sure you're okay. People that have been working on homework questions with me, it's time to kind of shift gears back to your notes. So in your notes, let's see if we can do at least 3, maybe 4 examples. Remember, the goal of today is, you know what, pause, we gotta write down our little snippet from today's notes. We did this example, but we didn't get to write it down. How do we solve a radical equation? First, we gotta get the radical alone. That means isolate. Then, I say use exponents. Use exponents. In this case, if we have a square root, we need a square root. If we're going to have a cubed root, we need a cube.
Is this 10.3 or 10.1?
Oh, if you check on the board, then you know it's always up. You just finished 10-1. You guys are
Correct.
turning in homework as you want. 10-1 was done. Isolate the radical term. Then eliminate using exponents. Isolate the radical term. Then eliminate using exponents. Guys, we do the example I wrote down. If I want to get, let's just go for 2 examples. Get 2 more examples. How to get rid of the radical in solving. How to get rid of the radical in solving. Isolate and use exponents. So here, let's go and just try number. Let's do number 1 at the top of this page. Who do I need to get alone? Who has the radical? Good. He does. How do I get him alone?
Square.
How do I get him alone first? Who do I need to get rid of? The 1. Now, if I do 1 plus 1, does that get rid of 1? No, I need 1 minus 1. So I'm going to get a little stuck on this. I'm going to have negative square root of c equals, what's negative 2 minus 1? Now the square root's not alone yet. How do I get rid of what's left? There's a negative. So I need to multiply or divide by a negative. There's no flipping, I just have an equals. Now I get square root of c equals 3. Question. Negative 2 minus 1 is negative 3. Now I need to move the negative sign. So I'm writing negative sign. Guys, how do I get rid of a radical? Square. Good. What happens on the left? C alone, right? What happens on the right? 3 times. 3 times 3. We're gonna skip 2. Where you guys wanna go? Just been focused the whole class. This wouldn't be hard. My question on 3 and 4 actually isn't, can you solve it all the way? I just wanna know, can you start? What would you do in 3 to start?
Square it.
Subtract 1 and
We've been moving stuff around, but my question is, aren't that radicals already kind of alike?
yeah, you need to square it.
So we need to go ahead and say, you know what? There's actually nothing to move. It's time to square right away. And what's going to happen with those radicals?
Yeah, it's square. So 3x plus 1
So it's going to be 3x plus 1 equals 4x minus 7. And now we're going to solve our equation. Now, Alan and the rest were distracted. I just want to put a dot, dot, dot. I'm hoping you know how to solve for x. After that point, it's review. Pause. I just want to know how to start. So 30 seconds till you form it. What do you think we do on 4? Is squaring and no. We're not graphing, we're just trying to solve. What undoes a cube root? Barry, you're right. Justin, you're right. A cube will undo a cube root. Some of you might need your calculator to do this, but 10 times 10 times 10. Why am I putting a dot, dot, dot? What's your job to get a lum? C. And what's your job to get a lum on this one? Kiddos, that's this. In its entirety. Make sure you have a picture. You guys should have already written it down. You just showing Aiden and Jabby. Homework. Oh, sorry, give me the mail. You have homework, you can put it on the office desk if you have it here already, or give it to me on the way out.
Stuff on the purple book. He said that I didn't do my 9.0.
You usually
Okay,
stay
boy.
here after 3 hours.
I'm good, man. It's still good.
And they're like talking. I just can't do it. Every day so I can pick up.
Most lunchtimes, like today I have a meeting, but yeah, come in lunchtime or
I can start. I'm not doing it.
answers for
I was juggling my I'm sorry, I was secretarying out the thingies.
It's okay, I did horrible.
for 7th grading convention.
You know how you chicken nuts?
I don't know.
Okay, he messed up on that. He fixed it today, but he accidentally crossed it. Just
Did he fix it too?
Yeah.
Like,
camera?
That's why I had Brandon.
I did it.
I like it.
After Brandon said, I was like,
I was scared though that Mr. Will would take my phone away.
I just hear class, so I sit here all the time. Is that weird?
I'm here to fail my quarter final.
I
That's what I forgot my watch.
Oh, I got minus. Actually, no, I got an A. But I got -5.5.
Sign language or did you want?
Just know the integral of u, p to u does not have a u prime. Because I did that wrong.
Does it?
No. Oh, did you not know that?
What? I literally was just studying.
There's no u prime.
Why?
I don't know. It was really difficult. I guess if you were to take the integral of it, you would be doing offset. So when you solve for du, you would get that. Yeah. Yeah.
Is the integral of
Because I
like,
feel like you don't think that's why I was like make sure that
integral of
we're
like,
like actually break
if
it
you have
down.
like an L
Because I think that we're gonna say that and then tomorrow they're gonna show us
You-
and then, oh I didn't know we actually didn't bring something. Go ahead. Because I feel like
I think I have like the calculator.
I
Got a
got
textbook.
no actually that's funny. If you don't bring something you get a bonus.
Yeah.
Well, as long as you're doing an act.
Chemistry.
So I sort of like activities for the ones that are still.
Why?
Did you ban?
Doesn't
matter.
Also I definitely got the list.
Yeah, regardless of
But I
what you
don't
do.
know where I put it.
I'm taking
I think
it.
I did.
I've been.
It's so fun.
Very cute.
I don't know why. I hate myself though, because I'm taking the 3 of the hardest
All of
things
us
at the
will be
school.
here for
Bio, chem, and physics.
lunch and after school tomorrow.
No, physics.
And eventually I said,
But I'm taking 4. Because why not hate yourself more, you know?
We're gonna be fine.
I don't know what else. I mean, we have to talk to you. But we're not at that point yet.
Alright, like,
We'll talk about it next.
no reason not to interrupt.
Because I only know.
And that's also the derivative.
You know,
What, L, 1 over X, L.
But we keep asking for it, like, I'm not
so
thinking.
they said
Oh,
how
yeah.
many and then you have to go.
Those books.
This is so confusing. So many
That's what you know.
I'm gonna have it wrong.
We can't do it, but then.
Alright.
But let's say